All right, welcome back. I hope you're having an awesome time so far. I'm excited to introduce our next speaker, Elena Kuliak, who is the Director of Scaled Analytics at Nike. Please join me in welcoming Elena to our virtual stage.
Hi, everyone. I'm really happy to be here and to be a speaker today. I wanted to start by giving you a few details about my background. My journey with AI and machine learning started about a decade ago at MIT, where I met my statistics professor, with whom I worked on his first startup. Soon after graduation, I joined Select, which was the startup he built. And as part of Select, that is actually a cloud-based predictive analytics SaaS platform that helped retailers optimize their overall inventory position. As part of that startup, I led and was part of over 30 implementations with retailers around the world. My focus was fashion and apparel and accessories. So I hold this industry very close to my heart. And currently, after 4 years of operating as a vendor, Select was acquired by Nike about a year and a half ago. And now I'm doing the same things specifically for Nike. So as part of my experience at Select and at Nike and at other jobs that I had before in AI and machine learning, I learned a lot about how to make a product successful. And I've seen a lot of cases that did not generate the desired outcomes. So what I built for myself is a framework of how to build a successful AI product for retail that I would like to share with you today. And that framework is based on 3 steps that I want to talk to you about. First of all, the steps is how do you find a friendly AI problem? It turns out not all of them are friendly. So that's kind of like prerequisite for building something that stands the test of time and is actually useful for the company. Second step is designing a product, AI product, and an implementation that actually fits with your business and is compatible with the way you did things or the way you do things or will be doing in the future. And the last step that is very frequently ignored and kind of taken as a afterthought in the aftermath of what happens when you go live with a machine learning algorithm is measurement that is very tricky. And I want to spend a good chunk of my time talking specifically on how to do it right and how to protect your product from incorrect measurement that might actually end its life. So let's start with the beginning. Answer the question of how and where in retail should we use AI to make decisions? And I would love to start with the retail cycle overview. And where exactly in the retail cycle is it better to be with an AI product to begin with? So the retail cycle starts with planning, as we all know. It's about 18 months. It's focused on high-level decisions about the quarter or the season you are looking to plan, and it has things evolving around revenue, margin, roughly what is your breakdown of categories, how many percent dresses do you want to buy relative to shoes, to pants, and so on and so forth. Giving a fashion example here. Planning is quickly followed by buying, which is more concrete, where you actually decide what product do you buy and what quantity. And that's where you sort of decide what is going to be produced for your customer 3 to 12 months before sales. Quickly, as the products get produced and delivered to your door, we start thinking of allocation. Allocation can be of many kinds. You can start thinking about allocating your merchandise between distribution center for your e-com channel or for your brick and mortar channel. And you can also think about allocating merchandise to your stores. So all of that happens somewhere between 1 week and 2 months before the sales season. And then ultimately you have the in-season pricing, which happens after allocation, where you are adjusting to the demand and you are adjusting the price of your goods or whatever it is you're selling or the merchandise you're selling, you're adjusting it to demand. And that usually happens days before you adjust the price. Ultimately, the goal of all that is to deliver and generate sales. And sales is where you get to understand whether you did a good job on all the prior stages of your planning, buying, allocation, and season pricing. And ultimately, after the sale occurred, particularly in e-com channel, you actually have to make some fulfillment decision on whether to use your inventory in the store or in the distribution center to fulfill online demand. And that usually takes minutes or seconds, depending on the algorithm you use. So all these stages are actually compatible with some version of AI. But one thing that is very interesting about the early stages is generally the return on investment for the right decision is higher. That means that if you did the right thing early on, you're going to really benefit from that decision because it's very consequential. Now, later on, the decisions are basically less consequential because you're reshuffling the inventory you are already committed to buying. So although the benefits are not so high, these stages, the later stages of retail cycle, are much more friendly to analytics implementation and AI and machine learning because they don't need so much time for forecasting. So if you're planning for 18 months in advance, your forecast and your anticipation of what will happen a year and a half from now, the accuracy of that prediction is going to be low because it's so far out. And when you are in season and you have days, weeks, or seconds to say what the right decision should be, your forecast accuracy will be very high. So from an analytics perspective, the later stages on the retail cycle are actually more beneficial for data science. Another aspect to it is obviously measurement. And although the planning and buying are so consequential and so important and can be compatible to AI, it's virtually impossible to understand what the impact of AI inside those stages is because they are followed by so many other decisions that can either improve the impact or erase the impact of a positive decision, and you'll never know what happened because so many decision notes happen afterwards. So let's take an example right now of what is a bad retail problem. So a bad retail problem that actually something I analyzed with my team about 5 years ago was coming from a high-end fashion retailer where they wanted to find out what sizes of Manolo Blahnik stilettos should they keep in a store. And they wanted to know the answer to that question for that specific shoe you see in the picture 9 months in advance. They wanted to know the right sizes. And we quickly looked at the data and we analyzed the data and we saw that the sales for March, April, May, June, July, those were the months of historical data we had available. Unfortunately, we only had like 8 observations and we had no algorithm or no idea how can we predict with accuracy based on 8 observation what will happen 9 months from now. And obviously what we recommended to our client at the time was, hey, can we rethink the problem? Maybe the right question to ask is, how many pairs of shoes do you need for North America for the month of March, April, May next year when your season starts? But let's start with a rough understanding what that volume is, because with such a question, we can aggregate all the historical data of sales and answer a higher level question of higher granularity with more accuracy. So that is an example of an unfriendly approach to data science that allowed us to build a framework on the dimensions of friendliness of an implementation. So there are actually 2 dimensions. One of them is the lead time before sales. So when you have 1 or 2 days or a month before the sales occurred and you're somewhere early, late into your retail decision cycle, you're in a very good spot. When you're far out, like we were with the Manolo Blahnik shoes, 1 year out, that's kind of tricky because you have to predict the future so far out, and algorithms generally, the further they go out, the less accurate they are. There is another dimension, which is the dimension of granularity. Is basically also covered in that unfriendly example is, do you want to predict the stiletto sales for North America, or do you want to predict this specific shoe in the Florida store on that specific day, on that specific month? So the higher the granularity, the friendly the model it is. to the implementation. So the place you want to be in is probably, if you really want to stay granular, it's probably somewhere on low granularity, short period of time. So a classic question here would be, how much should I discount the product X in store Y tomorrow? That's a great question to ask. It's low granularity, but it also has low lead time. Also, an okay problem would be, what should be the share of X or Z category next year for the buy, to do my buy? And that's okay, because although this decision is 1 year out, the granularity is high and the model is friendly to that. You can also ask in-season questions such as, where should I move all my inventory from one distribution center to another that are high granularity and low lead time in season? One place where AI fails consistently, and coincidentally, it's also where everybody wants to get an answer. It's when you have a long lead time and very low granularity, and that is exactly why that example was such a telling story of how not to approach AI questions. So basically, if we were to go back to our retail cycle, we know that planning, buying, allocation, ISO, pricing, sales, fulfillment, all these stages can have some sort of an implementation, but the friendliest to the nature of what machine learning and AI is doing is kind of on the right side, because those are operational instant decision. So you act upon them in season, it's an in-season response, and you can adjust the plan on the go and let those analytic implementations and products kind of run autonomously. So this is autonomous decision making, because what is good and what the objective is for those decisions is fairly clear. Where you need creative thinking and where you need strategic thinking is actually on the planning buying side, where you need tactical decisions and long lead times. You identify strengths, you brainstorm concepts, you shape your brand strategy. And all these things are generally not friendly to AI, but they can be informed by some data pieces that the team that leads that effort can take as facts, as data, to make better decisions. So although you can still make implementations on the left side, you need a higher human interaction coefficient for those types of decisions. So that kind of concludes the finding the friendly AI problem stage. And let's move on into designing the AI product and the implementation. So how do you design a product? Well, first of all, what is a product? What is the difference between a data science analysis and actually machine learning product that actually makes decision independently? A data science product, a data science analysis, and an AI product, the difference is actually the product takes over routine and makes repetitive decisions on a systematic basis. So it kind of, you can let it go. It's going to run with minimal supervision, or maybe independently in case of fulfillment, but it can do it. So when we talk about classic components for an AI product, we talk about, first of all, historical data. I'm not going to talk about the importance of data. Right now, we all know how crucial data is to any forecast. But if we were to summarize what data actually means, it's basically what happened in the past. That's a question that data answers. What was the story in the past before I came with my implementations? The second stage of any product is the forecast. And the forecast answers the question of what is likely to happen in the future in the light of what happened in the past. Then we have one of the most important stages of product design. It's the optimization, where we decide to make a trade-off with our resources. We decide how to arrange our resources to achieve a desired outcome. So basically, we're answering the question, now that I know what is likely to happen, how should I use my resources to reach the outcome that makes me happy? Following optimization, that is the heart of what we're aiming for, whether we optimize margin or revenue, it's the constraints. Constraints are usually what I am not willing to sacrifice in my quest for perfect outcome. UX, UI, where the user kind of designs, the user and the team designs the interface, the communication stages with the product, and then ultimately the enforcement mechanism that operates how a result, a recommendation for some type of decision should be ingested by either pricing, allocation, fulfillment, or any stage of enforcement of decision you're talking about. So let's take a pricing solution. What would be the historical data for a pricing solution? It would be historic prices, transactions, inventory, product information that all get fed into the machine that creates the forecast of what is likely to happen. What is likely to happen given what happened in the past? And because we're talking about a pricing solution, it's probably going to be demand at different levels of prices. After the forecast, we get to the optimization stage, where we answer the question of, given what we want to maximize, which is normally margin or revenue, how should we price the product today? And ultimately, that decision, the optimization, is also informed by real-time constraints such as minimum acceptable price by retailer, or minimum margin percent, or other constraints such as age or age on the shelf before it becomes eligible for a markdown. And ultimately, you get the results. What is interesting here that the implementation is fairly dependent upon the process. So sometimes you can have a perfect product that does not blend in with the process or the way the user thinks. That's why you have to understand very well the process that operates before you even go with your product implementation. So let's take an example. We had a retailer selling shoes, and their allocation team was deciding what shoes would go to what category inside one big store. And they had three people deciding three categories: men's running footwear, men's tennis footwear, men's fashion sneaker. And each of these people was operating in silos in these boxes of space inside the store that they had control over. And very quickly after the implementation started, we realized that this is not actually giving us the opportunity to shine with the algorithm we were hoping to implement. And why wasn't it friendly? Because actually you don't want to keep those types of shoes siloed. You want to open up the store and allow the algorithm to decide what share should be increased based on demand signal. Maybe we don't need that many fashion sneakers. So we only need one person to operate the algorithm and instruct the algorithm what constraints are reasonable to optimize the entire store. For instance, in this case, we took away those silos out of the equation, and we could see that tennis footwear required more space because demand was asking for it, or eventually, fashion sneaker was not popular at all, so it wiped it off. But all these things would not have been possible if we did not take away the silos, and basically what the algorithm would be doing, it would be operating inside the silo. So that's a great example for how to change the process to make it more friendly to an implementation that you are designing and building. Now, one in my personal opinion, one of the weakest points and the most frequent in terms of failure is usually the measurement. And what is the key to a successful measurement is to design it before you go live. The worst thing you can do is go live with a product, not think through how you're going to measure it, and then kind of scramble through the data half a year after to make a point that it actually works. I have seen that happen many, many times. And what I can tell you is that measurement should receive just as much attention during the product build as any optimization or process redesign or anything else. It's very, very important to get this and think this through while you're designing the product. And basically what I want to answer here is, how do we measure success? And not only that, how do we monitor the product as it goes live? So one thing you need to remember as you design your measurement strategy is, what is your objective? Are you optimizing for revenue or margin or something else? So the question you're trying to answer with measurement is, to what extent did the AI product achieve the optimization objective? That's number one question. There's another question that is sort of a function of the first one, is what's the adoption rate? What percent of AI recommendations were executed? And why is it so connected with the first question is because you can only measure the impact of those decisions that were actually taken through the AI. If there is a shared decision that was not taken by AI for whatever reason, you need to wait to record this and differentiate between the impact of those decisions that you control as a product owner or as an engineer, and those that you do not, so that you can isolate the right impact. So how do you do it? A lot of implementations I've been part of early on in my career were tending to fall into this loop of hey, we designed a product KPI, it was live, a product, it was live for about a quarter, and then we saw that our financials or our margin went down for whatever reason. Well, maybe the product is to blame. Well, that usually is not necessarily the case. The product is not to blame. It could be, but it could not be. It's very hard to make a direct link between those two events. But what it tends to happen is that you end up killing the product in the infancy because you did not think through the measurement. So to prevent this from happening, you need to design product KPIs that speak to the quality of forecast or the optimization of how well is the product doing, and then bridge them over to your business KPIs, which are the KPIs that are known as sell or weeks of supply that could be directly or indirectly related to your objective, the optimization objective you're building. And only after you bridge over the product KPIs to business KPIs can you actually make the connection with your financial KPIs. And the bridge that you are constructing and the way you are translating those KPIs into each other has to be thought through and designed well before you go live. Why is it so important to do it well before you go live? Well, as we know, the product doesn't live in a silo. The product has at heart your best interest, making more money usually, but it's operating with lots of people and other systems and different things that you need to understand, so you understand how do they impact the performance of the product. So it's very important to keep the heartbeat of your product under supervision to understand how it's performing in the context of all those moving pieces. Whether it's some other implementation going live at the same time, or some user that's inputting constraints that are not in the best interest of the KPIs that are product KPIs. Similarly, you have to keep an eye on what those constraints are. What is the business doing beyond the product that could actually affect your results? So designing a data infrastructure that monitors the performance of the product is crucial because it requires a lot of engineering work from your data engineers to create those pipelines and monitor the heartbeat of your little AI baby and also everything happening around him. So that way you can track adoption, product KPIs, business constraints and circumstances, and ultimately business KPIs. And if you iterate long enough through the cycle and you perfect your product over time, eventually financial KPIs will fall into place and you will be able to bridge them and make a point that it's actually successful. So that takes us to the summary of this presentation. How do you build a successful AI product in retail? Let's recap real quick. First of all, you find an AI-friendly problem. It's not absolutely necessary, but generally more autonomous problems live later in the retail cycle, which is allocation, in-season pricing, and fulfillment. But you can also go early on. If you design it with a high interaction element, then you have to think through the implementation and change the process to leverage the AI capability and make sure you're not sabotaging your AI results because of process that is incompatible. And the last one, make sure you plan all the way to the end and build a KPI approach that allows you to monitor the performance and perfect the product over time. So these are the 3 stages for the framework that I wanted to share with you. Thank you all very much and really happy to be here and looking forward to hear everyone's questions and opinions. Thank you.
Awesome. Thank you so much, Elena. If you could stop sharing the screen so the audience can give you a huge virtual round of applause. Thank you. We really appreciate you sharing this knowledge with us. It's incredible. All right, for the audience, it's time for you to make your way to your next session. Along the way, make sure you accept your connection request and check out our amazing AI exhibits. Thanks so much, and we'll see you around.